Hey guys, I just wanted to show you a quick experiment that I think is really helpful for visualizing the difference between open flame exposure versus just high ambient temperature in the context of the hybrid-Aramid tethers like Kevlar and Technora for poi. So I have a little piece of Technora here, and it is it's marketed as having a maximum temperature rating of 932 degrees Fahrenheit. And what we're going to do is just wrap it in aluminum foil to protect it from the open flame, so that we just heat the material up without exposing it to the open flame, so you can see the difference. So first I wanted to show you how aluminum behaves under, this is a Zippo lighter with Coleman white gas in it, and you can see that it melts the aluminum. Okay, aluminum melts at 12 to 1300 degrees Fahrenheit, which is about 12 to 1300 Fahrenheit is a pretty representative temperature of the temperatures you expect to see at or near the wick of a poi. So we can tell by melting it that this flame is going to produce a temperature of around 12 to 1300 degrees Fahrenheit. So what we're going to do is take the Technora and we're going to wrap it in aluminum foil, and I'm going to press it very firmly closed, making sure that the Technora is very intimately in contact with the aluminum so that we get a good thermal transfer. I don't know if you can see it, but you can actually see the impression of the Technora through the aluminum, so we know it's got a good contact. Okay, and then I'm just going to cook the crap out of it. Okay, and I don't know if you can see, but the aluminum is actually like shying away from the flame, which indicates that it's melting. So the aluminum is reaching a very high temperature, 12 to 1300 Fahrenheit at least. Okay, and I'm just gonna, if I can hold on to it long enough, it's getting awfully hot, but I'm just gonna cook the living crap out of it. I'll do the other side as well. Okay. Alright, that's probably good. Now we're going to take the Technora out, and you can see that it has discolored. Okay? It's sort of a brown, a deep brown, like chocolate color, almost black. But it has plenty of integrity still. Totally fine. Right? It may have deteriorated a little bit, so we'll see some fraying. I'm not seeing too much, but you can see how long I cooked it for and how well it held up to that high temperature, at least 12 to 1300 degrees Fahrenheit, because the aluminum was melting. Okay, and now I'm going to do the same thing over an open flame to show you the difference. If I can get this guy lit. There we go. Alright, ready? So the difference, see how immediate that was? Poof. Okay, and you can delay that by increasing the thickness. For example, I'm going to take 2 strands and fold it in half and then twist them together, so I have a total of 4 strands worth here. Okay, and we'll try the same thing, and you can see that it improves, but it's still completely disintegrating, and you can see that you get a lot of fraying, right? A little bit more fraying, until you get through the whole thing. See, we're down to like nothing. So you can delay the inevitable failure of the tether by increasing its thickness, but you're only delaying the inevitable. So it's important, in my opinion, to keep the flame well away from the actual tether, or keep the tether well away from the flame. And we found that 5 inches of chain used as a buffer between the head and the aramid tether attachment was sort of like the safest minimum that we could come up with. So hopefully that makes sense. Yeah. All right. I'll see you guys later.